In this video, we're going to talk about the Earth systems. The goal is to identify the four systems of the Earth and describe how they interact.
Okay.
Earth is a very complex system. Although it looks like one large structure, it actually got a lot of things going on. A system is a set of interconnected components that are interacting to form a unified whole. So for example, an ecosystem. So the organisms are interconnected and interacting. So the concepts that you need to recall here are the food web, food chain, commensalism, mutualism, etc.
My head.
Earth is defined as a closed system. So when we say a closed system, there is only an exchange of heat or energy and no exchange of matter. For example, the sun gives energy. This energy reaches the earth, but it bounces back to the space. No exchange of matter means that nothing or no matter disappears. It just spreads out to other forms. Now, Earth has four systems. Number one is the lithosphere. It came from the Greek word lithos, which means rocky. The lithosphere is the rocky portion of the Earth. Next, we have hydrosphere. Came from the root word hydra or hydro, meaning water. Third is the atmosphere. The atmosphere came from the word atmos, which means steam or vapor. Lastly, we have the biosphere. It came from the root word bio, meaning life.
Got it.
So let's start with the lithosphere. The lithosphere includes the crust, the mantle, and the core. That's why it's also called as the crustal system. Some books they call lithosphere as geosphere. However, there is a minor difference between the lithosphere and the geosphere. So the lithosphere is rigid and mechanically strong outer layer of the Earth, and it is divided into 12 major plates. On the other hand, the geosphere is the solid body of the Earth. So for this class, we're just going to use lithosphere for the lithosphere, hydrosphere, and atmosphere. So we're going to use lithosphere to avoid confusion. One important process that happens in the lithosphere is the tectonic activity. So the tectonic activity describes the interaction of huge slabs of lithosphere, or commonly known as tectonic plates. These tectonic activities are the one responsible for some of the geologic events, such as earthquake, volcanic eruption, volcanic formation, and it is driven by the Earth's internal heat. It is said that the Earth's internal heat flow to the surface is thought to be 80% due to mantle convection. So mantle convection describes the movement of the mantle as it transfers heat from the inner core to the lithosphere. Next, we have the hydrosphere. This is the total amount of solid, liquid, and gaseous water on Earth. It ranges from 10 to 20 kilometers in thickness. In some books, they have this other term or other sphere called cryosphere. It is the frozen part of water. But remember, it still falls under hydrosphere. Now, the hydrosphere is about 70% of the planet, and much of the water is in the form of ocean water. Of this 70%, only 3% is fresh water and 90% is salty water. One important process that happens in the hydrosphere is the water cycle. So the water cycle describes the continuous movement of water on, above, and below the surface of the earth. So this is the complete water cycle. So we're not going to focus on this because that would be for another lesson. Next, we have the atmosphere. The atmosphere is the body of gases that surrounds the planet. So it is also called as the invisible shield. Why? Because it simply protects the Earth from UV radiation. The atmosphere is located close to the Earth's surface where it is most dense. So now let's talk about the composition of the atmosphere. The atmosphere is composed of 78% nitrogen, 21% oxygen, and 1% inactive gases. One example is argon. Argon is just 0.9%. So what is the role of the atmosphere? So the atmosphere supplies oxygen, carbon dioxide, and nutrients to living organisms. Also supplies water. So remember, water is part of the hydrosphere. This shows a simple interaction among the atmosphere and the hydrosphere. The atmosphere also protects the living organisms from extreme temperatures and excessive UV radiation. So we have different kinds of UV radiation. We have the UVC, UVB, and UVA. UVC has the shortest wavelength, so it is easily reflected or deflected by the atmospheric ozone. UVB has the largest effect on the top layer of skin. But don't worry, by staying at home, the exposure to UVB is less. However, we have the UVA. So the UVA has the longest wavelength and therefore it may penetrate your house or any protection basically. That's why you use sunscreen even at home. So UVA is one of the source or the cause of wrinkles. Now let's go to the biosphere. Oops, wait. Now this biosphere includes all living things on planet. Okay, the animals, humans, etc. The earliest life form is about 3.5 to 3.7 billion years ago, and these are the microorganisms or microbes. One type of microorganism that formed are the prokaryotes. So these prokaryotes survived without oxygen, and now we call them anaerobic microorganisms. In the biosphere, there are different ecological communities, or what we call biomes. Some examples are the tropical rainforests, tundra, and the desert. You can find some living things on the desert, but you can't find them on tundras. So the biosphere is considered as the carbon dioxide sink or the carbon sink of the earth. So a carbon sink is actually a reservoir that absorbs and stores the atmosphere's carbon. Take note that this is not a carbon source. It actually gets the carbon. Now there are two types of carbon sink, the natural and the artificial. So an example of natural carbon sink is a tree, okay, or a forest. They absorb carbon dioxide from the air. Artificial carbon sinks are of course are of course Artificial carbon sinks are of course man-made. One example is a process called artificial carbon sequestration. Now this carbon sink is important for the carbon cycle. This diagram shows the carbon cycle. Again, we're not going to focus on this. The carbon cycle is the biogeochemical cycle by which carbon is exchanged among the biosphere, geosphere, hydrosphere, and atmosphere of the Earth. So basically, it's the natural way of reusing the carbon atom. So pause this video and
Drink your water.
although the four systems have their individual identities, there is important interaction between them. There are 10 possible types of interactions that could occur within the Earth system. So 4 of these interactions are between the event and each of the Earth's sphere. This could be represented by this figure. The double-headed arrow indicates that the cause and effect relationships of these interactions go in both directions. The event affects the hydrosphere, but in turn, the hydrosphere will give something. So it's a mutual relationship between the event and the hydrosphere or any other spheres or any other systems. Okay, so let's have, for example, an interaction between hydrosphere and an event. On May 18, 1980, Mount St. Helens erupted. So this is our event. This event altered the surrounding environment. In this case, the hydrosphere. It could be the ocean, the river, or anything. So maybe the water became polluted.
I don't understand. I don't understand.
So you must remember that one event can affect many spheres at once. The eruption can affect the atmosphere or the lithosphere. So this event caused chemicals to form or to be present in water. This will provide scientists the information that they need to study volcanic eruptions. So that event gave something new which is useful for the people. Well, at least useful for the scientists. So this is important because volcanic eruptions will continue to occur and will have increasing impact on humans. So you might get confused, why is it not event then lithosphere? Or so why not event then biosphere? Because humans are part of the biosphere, right?
Yes.
In this scenario, we're describing the event and the water. So think of the sphere that is directly affected. Although both reasonings are correct. As I said, one event can affect many spheres at once.
My brain has completely turned to mush.
There are 6 more interactions that occur among the spheres themselves. The 10 types of interactions that can occur within the Earth system often occur as a series of chain reactions. So this means that one interaction leads to another interaction, which leads to yet another interaction.
My computer was confused too.
Just like the example a while ago, with the event hydrosphere then affects the lithosphere, or event hydrosphere affects the biosphere. It is like a ripple effect or domino effect. So let's have, for example, volcano then complex interaction. So volcanoes from the lithosphere may emit large of quantities of sulfur dioxide, which will affect the atmosphere air. When these sulfur dioxide combine with water, sulfuric and sulfurous acid form. Okay, so the rain may bring these acids to the earth, acidifying soils, lakes, and rivers, which are part of the hydrosphere. Now, the acidic water leaches nutrients from the soil into the water table, which makes the soil less fertile for plants. The water supply would also be less potable. In that one scenario, 3 spheres already interacted, but it's not yet done.
Are you serious?
This acid rain will soon fall to the lakes and bodies of water, which reduces the pH of the water. So when the pH of water decreases, making it more acidic, some life forms might be affected. For example, the phytoplankton and zooplankton. Now, if photosynthesis is reduced, carbon dioxide can build up. And again, if carbon dioxide increases, it will result to global warming, which is the atmosphere.
Sir.
This, in turn, may contribute to increased melting of glaciers. Can you see how one event affects the whole system? So humans can actually contribute to these events.
That is all I have to say.